So we're going to begin the morning by having this first session discuss the latest science. Much of this is already produced in written form in the annual science update that the Science Advisory Panel has been producing for the CCAC for these past several years. And so the 2016 version is now perhaps already on the CCAC website. If not, okay, on the website and probably emailed to you. We're going to go over that a little bit. I'm going to start. We're going to switch amongst the SAP members so you don't have to listen to me all morning. I want to start with one really key point which we already heard mentioned this morning, but I think this is going to be especially important throughout the day. Not only in considering what CCAC is doing, but in what CCA is doing relative to what the world is doing now that we have the Paris Agreement. And the Paris Agreement has really solidified this focus on long-term temperature targets with this powerful language of aiming well below 2 degrees in the long term. But climate is not only a long-term problem. Climate change is really here now, and I really want to emphasize that because I think I'm essentially, preaching to the choir here. But it's important to be reminded of just how large the changes that have already taken place are, right? Things like the snow cover having declined in the summer in the Northern Hemisphere from 9 to 3 million. Right? It's not as if a small fraction has been lost. 2/3 already gone away. This is not a problem for the distant future. Very hot days, the kind that you might see in the 2% warmest of land areas, now cover 1/3 of the hemisphere during the summer. Right? So these kind of things are already happening. Various parts of the world are drying out, heat waves increasing in other parts of the world. The consequences will certainly continue to get worse if we follow a path of emissions growth. But that doesn't mean that the consequences aren't already present now. There are many impacts in the cryosphere. We've already heard some of the mentions of that. Some of those are also very alarming and taking place very rapidly, including Arctic sea ice, retreat of glaciers around the world, advancement of polar permafrost towards the polar regions, and we're seeing the biosphere respond. Trees, butterflies, birds, lots of different species all around the world. When you think of the temperatures, all of these are the real impacts we care about, and so global mean temperature is a nice target, and I tend not to focus on it because it's a proxy for other things, but it's not what we care about the most. But if you think about global temperatures, I think that's worth focusing on what's happened there too. 2014, a new temperature record, only to be broken again by 2015, the warmest temperatures on record. And so far, we're only in March, we haven't gone very far in 2016, warmest January on record, followed by a February so warm it was not only the warmest on record, but it broke the record for how much it exceeded any previous February. And if you compare the February temperatures with temperatures going back to the end of the 19th century, that month was over 1.5 already, right? So it doesn't mean the annual averages got there, but the noise from the month-to-month variation is already, we've gotten so warm that we're hitting 1.5 in the warmest months. That's pretty dramatic. So that, I think, should be, both a call to arms to do something about this, but also, really highlight why the CCAC is so important. We're targeting those things that affect the rate of climate change in the near term. So, of course, one of the main reasons we're here, and perhaps the main reason for much of the world, is the public health benefits. When we did these studies all the way back to 2011, the basis for much of the CCAC, with UNEP, WMO, jointly sponsored an assessment where we looked at the impact of control measures, and millions of lives were saved. I don't expect you to read all the details of this, but this is from the Time to Act brochure that's also available on the CCAC website. So enormous public health benefits, that motivates our actions. Climate benefits, very profound. Again, in the near term, you have a great deal of leverage over climate change. And the UNEP WMO analysis, you reduce the rate of warming by about half over the next few decades, whereas CO2 has leverage in the long term. Very distinct, and I think we're going to be returning to that over time. The climate impacts are both beneficial when you reduce SLCP emissions and long-lived greenhouse gases, but they operate on very distinct timescales, and it's part of a package. You want to target both of these things. You can see there, if you can figure out the lines, or if you've seen this before, that the only scenarios that keep you anywhere within hope of achieving the low temperature targets in the long term require reductions in both long-lived and short-lived. There's these massive benefits for agricultural yield, and these include only the benefits due to reductions in ozone, which is especially toxic to many agricultural crops. So we'll return to that in the science update, but this is all just setting the introduction. There are some things we don't talk about as much, but there are certainly other consequences of other benefits to targeting SLCPs early on, and that you have some effects like melting of glaciers or sea level rise, which are cumulative. Right? It's the total amount of heat going into a system that has an enormous amount of inertia, and so the earlier you take that heat out, the less eventual consequence you get. So in terms of global mean surface temperature, you could put off dealing with SLCPs for a long time and wouldn't have that much impact. But in terms of any cumulative effect, like sea level rise, there's a clear advantage to taking these kind of actions early. And so just to go over in terms of the basic rationale, we had identified many measures that would reduce emissions of BC and co-emitted pollutants. I think it's important to always remind any people when we talk about these things that we're always looking at the net impact of all pollutants that are emitted. So we might refer to these as black carbon control measures, but that's really never what we're looking at. We're looking at reducing a whole bunch of things that come out when you burn inefficiently, right? And so there's certain measures that can have much more better chance of giving you climate benefits than others. And those are the ones we target. So there's just some examples shown up there. We have similar measures for methane. I think one other thing that we sometimes forget is that it's really easy to put these into place now in comparison with some others. Doesn't mean it's easy. I probably shouldn't use that term. But it's comparatively easy in the sense that none of these require development of new technology. Right? These are all things that we know how to do and have done. What we're talking about is scaling up and broadening things that have been put into place somewhere in the world. Right? So that we have these for incomplete combustion that target black carbon, we have these for methane, and we have these for HFCs. So there's a nice picture over on the right of American do-it-yourself HFCs that you can buy in Home Depot that was taken right here in Washington, D.C. So you could go get your own and refill your air conditioner, and if you accidentally miss putting the hose in and release them all to the atmosphere, oh well, right? So maybe this isn't the best idea. This is what happens, though, in the United States. So we have a lot of obvious targets, and of course that's what the CCAC has been working on. We're going to switch now from that background. I apologize for anybody that was old hat to, and we're going to now turn to all the new things, primarily focused on the last year. So we'll begin with Ravi.
I'm going to talk mostly about methane and HFCs. So just so that this slide pretty much summarizes what I want to tell you about methane, a few factoids. Just to remind you that methane is the second most important anthropogenic greenhouse gas. It is next only to carbon dioxide. Methane has a lifetime of roughly a decade, which is why it is in the CCAC portfolio and one of the short-lived climate forces. Indeed, it is actually the shortest-lived major greenhouse gas that is directly emitted. So it would produce some quick response if mitigated. Methane is also a source of tropospheric ozone, so its mitigation has air quality and health benefits. Methane, like many things, has both natural and human-induced sources. The key question that comes up is how much comes from where? And in fact, I could add the question, how much comes from where and when, as you'll see. It's almost exclusively the component of the natural gas, a major fossil fuel energy source. So let me just walk you through a few things about methane. This is the sources of methane. It's very varied. It has natural components, as I mentioned to you, that include wetlands, termites, oceans, and anthropogenic components such as energy production, enteric fermentation, rice and agriculture, biomass burning, etc. Both the total of methane is actually better known than the individual components. The imbalance between what is emitted into the atmosphere and what is removed from the atmosphere is what leads to the changes you see in methane abundances. Right now, it looks like there's more being emitted than being removed, so that it's increasing in the atmosphere. The sources are also highly distributed across the globe, and they vary with time. And it's more difficult to estimate these sources compared to CO2. You cannot know how much CO2 is coming in, or CFCs, and such what I would call industrial gases. Methane is growing again. For a while, on the left-hand side, what you see is the methane concentration in the atmosphere as a function of year from 1970 roughly to 2000 to the present. It was going up, and for a while, it looked like it would stop growing. But in the last decade, it has started going back up again, and that is showed on the right side, kind of enlarged. So the hiatus in growth rate has ended in this decade. The increase, the one thing we do know is that the increase is not because of any changes in the rate of removal of methane from the atmosphere. So we definitely know more is being emitted as opposed to a question of being removal. So the key questions are, what are the sources and how much are they contributing to it? So if you just did a tally of what could happen, rice, for example, changing management, the way things are going is likely to lead to a decrease in methane emissions. Certain fossil fuel sectors also could lead to decreases. Emission mitigation taken for various things, for example, fixing leaks and various other things are not pumping as much gas, could lead to a decrease. But fossil fuel emissions from hydraulic fracturing, it looks like it could be increasing. And also there are some indications that agriculture and wetland emissions are increasing. And of course, one always worries about the warming and release of methane from Arctic permafrost and hydrates and things of that nature. But the thing that we found out is that this is all new right now, and there's conflicting information and claims as to exactly how much each of these are contributing to the changes we have seen. But the point I want to make is the major sources are known. What is not known is how they're changing right now, but that does not mean you don't know where you could take action. Turning to HFCs, again, the first point I would like to make is that HFCs are essentially here because the Montreal Protocol successfully phased out the ozone depleting substances. Okay? And the thing that you see here is the strategy that is developed or adapted in implementing the Montreal Protocol. Things such as chlorofluorocarbons and halons were phased out, and for a while they were substituted by hydrochlorofluorocarbons. Incidentally, when my kid was little young, he used to tell me that was the longest English word he could write. It was impressive though. But anyway, And then you could go on to HFCs, which do not deplete the ozone layer to any great extent, but some of them are greenhouse gases, and there are alternative technologies that are also employed. So in this process over the last few decades, what has happened is HFCs are increasing. I just want to again emphasize that these are a collection of synthetic gases. They're here essentially because of the Montreal Protocol. Right now, they could be a major problem if you don't do something about them. There are HFC regulations in existence, and there are also some bilateral agreements. Now, as Jonathan Pershing pointed out, there are some initial considerations under the Montreal Protocol to deal with HFCs. Let me just tell you why you can't see that too well. HFCs are a big issue. This is a big building. I took a picture of this. This happens to be in China. The thing that you notice is if you focus on some things, I'm really sorry you can't see this. There are a bunch of air conditioners. But if you were to actually look closely, you realize there are a lot more windows without air conditioners than with air conditioners. And these people do want to have those air conditioners. So this is precisely the reason why these are not hugely increasing in developed world, but in the developing world, this is what's coming up. This picture is the growth of HFCs from China over the last decade, and it's increasing very, very rapidly, roughly 10% per year in consumption, emission, and of course, it's reflected in the atmospheric abundances of that. So if you look at the China's contribution itself, for example, what is likely to happen is it's going to kind of flatten out around 2030, but its effect is going to prevail. As you can see in terms of the consumption, emission, and the radiative forcing, which is essentially a measure of its impact on climate. If there are some proposed amendments to the Montreal Protocol. For example, one we show here is in 2013 is the North American proposal as to what is going to happen to HFCs for China if there is followed. And if something different that happened, if the phase down started in 2024, what would happen? But the point simply is the other developing countries are very similar to China, both in terms of their continued increases in their usage and potential for them to turn it around and start reducing HFC and through mitigation efforts. The simplest way I can get across this point, what is done is done. You can't go back and recapture what's emitted or CO2 or anything like that. So if you think about, I suppose you could talk about it, but if you think about what's going to happen in the future, the picture on the left to me tells the story. The gray area is business as usual for CO2 emissions going forward. The red is roughly what the HFC emissions could be if nothing is done. And the dashed line is the 450 parts per million mitigation strategy. The thing you notice is if you do your 450 ppm mitigation strategy for CO2 and don't do HFCs, you're back to the way it was. In other words, HFC, if you don't do something about HFCs, it'll completely offset all your efforts for dealing with CO2. But the world doesn't have to be that way. That's what's shown on the right side. There are options for using different kind of chemicals and alternative technologies to essentially avoid making this a big problem. So this is what I just told you already in words. And with that, I'm going to tell you one little thing about the fact that, again, as Drew pointed out, these things are feasible. It is not that you have to reinvent all this. There are technologies, alternatives, and various things that are indeed available. For example, going to hydrocarbons and the adoption of such technologies, they're actually available, as you can see in that picture. I'm sorry if you can't see it. in fact, what you can see on the left-hand side is the CFC usage was offset not just by the HFCs, but also by various other technologies. Of course, there are some further R&D that is needed. There's also another key factor for doing it, and in the process, there's major energy efficiency gains to be made in using these technologies. So it's a win-win in that sense. With that, I'm going to stop. Thank you.
Okay, I'm going to take another little turn up here and talk about some of the updates to our understanding of black carbon. So we've just heard about HFCs and methane. Black carbon is one of the emissions from incomplete combustion that we're concerned about, of course, and there's been a fair bit of new studies, a large number, really. I think one thing that's important to emphasize when we have studies come out from black carbon is that there really is a difference between a scientific assessment and a single study. And you have a bunch of individual studies that come out and they say, oh, no, now we're 30% higher. Oh, no, and the next one comes out and it's 40% lower, and then 10% higher. And so we really, in the panel, reviewing things, try to place extra weight when there's a real assessment process that tries to bring together all of this literature. So when you look at various individual studies, yes, pretty wide range of results, and some tend to bounce around compared to what's been happened previously. I would say that there's been a fair number that have suggested underestimates and a fair number that suggested overestimates as far as climate science. So our overall conclusion is that the basic picture of the climate impact is not profoundly changed by any of these new ones. When there's a new assessment, of course, by the community, we'll take that into account. We've also been looking not just at the climate impacts, but at studies that have looked at black carbon emissions. One thing that's been particularly interesting, I think, is to look at trajectories for projections. So Ravi was just showing those for HFCs. We have those for black carbon as well. For example, AMAP, the Arctic Monitoring and Assessment Program, did perform a community assessment, including black carbon, with their focus, of course, being on the Arctic. And under their reference scenarios, black carbon emissions do go down. So there's kind of some good news there that even in the absence of additional action, we expect to get some benefit. But it's a pretty modest benefit. It's not as if this problem is going away on its own. So they're set to reduce, but only modestly. Asia still remains the major source. We're even finding other areas that allow us to focus efforts, such as the importance of flaring and how that had been usually overlooked. One other thing that CCAC has done, which I think the science community appreciates a lot, is sponsor its own assessments. Thus far, the LAC assessment, Latin America and Caribbean, is complete, virtually complete. We'll hear some about that from Johan later today. And one thing that's allowed us to do is study the impact of climate policies. And so there are policies that are likely to be put in place as nations work towards low CO2 emissions. There had been some studies previously that suggested those would probably solve the problem for us. We didn't need efforts like CCACs. Those don't seem to hold up. They require some pretty unrealistic assumptions, and it looks from the LAC assessment results that climate policies alone will really make modest contributions. So I think it's important to keep these things in mind. We're probably on the right path, but we're taking it much too slowly. When we add in climate policies that are likely, hopefully, to come into play, that might make things even modestly better, but there's still a really important need for a group like CCAC to make these reductions happen much faster than they will under any of these other scenarios. We've got some new studies on the impact at the regional scale, including the especially large sensitivity in cryosphere regions, so more work on the Himalayas and the Tibetan Plateau, kind of enhancing the conclusion we already had that these regions are very sensitive. That seems to be further buttressed by recent work. And we have some additional studies that have looked at the impact of black carbon and all the other mixture of aerosols that come out with incomplete combustion, and they show that the absorption of heat by this thick and dark aerosol layer can really perturb local weather patterns, and it can influence extreme rainfall events, both in location and timing, and lead to things like flooding and such. So this is yet another reason for action based on the science for CCAC, and yet another difference compared to a long-lived greenhouse gas. This is a very localized climate effect, which may have very profound influence on society, but isn't captured based on analysis of global mean impact. Going again to a cryosphere region for the Arctic, as I mentioned, the AMAP, the Arctic Monitoring Assessment Program, has produced a new assessment. There's a few individual studies, and the LAC assessment, although obviously focused elsewhere in the world, includes results for the Arctic. And all of these, I think, are pointing in the same direction of how we're reinforcing knowledge that we could have very profound benefits in the Arctic in particular by reducing black carbon and its co-emissions. We're getting more information on ozone and how ozone affects crop yields, and in particular, the science is pointing towards plants being influenced by not just the peak exposure, but by the overall exposure throughout the year, which controls how much ozone really gets into the plants. And the longer-term background exposure is more heavily influenced by methane than by other ozone precursors. So that, again, reinforces the idea that if you target methane, you can get some profound agricultural benefits. Some of the new studies that are highlighted in the annual update find impacts as large as, say, 20% crop yield reductions in the worst hit places in Asia unless action is taken. So these are some pretty major impacts from ozone and climate. Again, reinforcing the rationale to act. Energy efficiency, as Ravi just mentioned, is another area where there's some really interesting possibilities for, I think, CCAC-related science to advance our knowledge. There's some work coming out, and the work that's coming out suggests that you can really get some major improvements from energy efficiency, both in long-term targets, long-term warming, and in near-term. So we're going to return to that in the next session. But there's some promising work coming out there, too. We're going to turn now to our last section of the morning's update with Andy Haines.
Well, thanks, Drew. So what I'm going to do is to give you a brief overview of the health impacts of short-lived climate pollutants and also the potential benefits from abatement. I'm going to start off with a brief kind of overview of what we know, and then say a few words about some emerging findings. Not because these are definitive, but because they do suggest areas that we need to do more work and are producing intriguing results which add to our understanding. So let me draw your attention to this publication of WHO and CCAC, which is about reducing global health risks through the mitigation of SLCPs, which really provides an overview of the evidence up to last year. And just to remind you, of course, that air pollution is a major killer. And this, of course, is not just short-lived climate pollutants, it's particulate air pollution in general. What it shows you is about 7 million deaths a year. And the reason I show it, many of you will be familiar with it broadly, but I just show it to emphasize the fact that many of the conditions that we tend to think as being caused by our lifestyle, by smoking, by blood pressure, by cholesterol, there's also a very important contribution of the environment, of air pollution. And this is really an emerging pattern of, which has emerged over recent years, but now I think has become pretty strong evidence. So stroke, shown in the orange or red, COPD, that's chronic obstructive pulmonary disease, which is in the brown, and heart disease, of course, ischemic heart disease, a major killer. But also acute lower respiratory infection, which is a major killer in children. So a lot of deaths due to pneumonia, and of course household air pollution in particular is a major risk factor, and of course lung cancer as well. So slightly different patterns between ambient and household air pollution, and of course considerable overlap between them because household air pollution contributes to ambient air pollution in many parts of the world. So this slide just shows you the regional deaths from air pollution. In the top you can see how it compares with tobacco smoking. You can see if you put the two together, it's certainly up there with tobacco smoking, probably exceeds it. So it's a very, very major risk factor for ill health and for premature deaths. And the bottom part shows you the regional pattern. So for household air pollution, you can see, as you'd expect, sub-Saharan Africa. In this case, they've shown eastern sub-Saharan Africa, where most of the deaths occur in sub-Saharan Africa due to household air pollution. South Asia and East Asia. In ambient air pollution, South and East Asia are dominant, but also considerable burden of disease in high-income North America as well. And then ozone pollution. We mustn't forget ozone pollution, 150,000 deaths a year, due largely to respiratory conditions, but maybe other conditions as well. And there we have big impacts in East Asia, South Asia, and of course in high-income North America as well. So that gives you a kind of bird's-eye view of the overall pattern of ill health. Looking at the different sectors, the WHO report also goes into each sector systematically and just summarizes what might be the SLCP-related climate benefit, the potential health benefit, the main types of health benefits, and whether there's any potential for CO2 reduction co-benefits. So, for example, the example of active travel, which means encouraging more walking and cycling in cities, has a whole range of benefits, not just air quality, but also a reduction in sedentary lifestyles. And physical inactivity is also a major risk factor. So about 3 million people a year die as a result of physical inactivity. It's an important risk factor for heart disease, for diabetes, stroke, and some types of cancer and other conditions as well. So this is a kind of strategy that is win-win on many different levels. Then when we get to diesel particle filters, they can have, of course, benefits for improved air quality, although, as we now know, not necessarily for NOx, but they will reduce fine particles. But of course, you don't then get the physical activity benefits. So that's pretty well established, but this is some new and a very interesting emerging evidence of the effects of air pollution on the cognitive development of children. So one of the emerging areas of research has been on the impact of air pollution on cognitive development and cognitive impairment in adults and children. There's some emerging evidence around Alzheimer's disease, but this particular study also looks particularly at children. Primary school children in Barcelona attending schools with either higher or low levels of air pollution. And this is a mixture of air pollutants, so we don't know which one is really important, but there's elemental carbon, NO2, and ultrafine particles are all there in a kind of cocktail, if you like, of air pollutants. And what they did was to look at the schools in high pollution areas and low pollution areas. And they adjusted also for socioeconomic differences. Interestingly enough, they found that many of the kids from higher socioeconomic backgrounds were actually in more polluted schools. So it wasn't just a matter of social disadvantage. This is a study last year published in PLOS. And this is just one of the outcomes of the study. They looked at a whole range of different cognitive function tests. And this shows you the comparison of the actually I think that's the wrong way around, because the working memory is actually lower in the high traffic pollution group, so we got that legend the wrong way around. But you can see that there's actually an adverse effect on working memory, which is a very important contribution to children's cognitive function. So this does suggest that there's an effect of being exposed at primary school level to high levels of air pollution on children's cognitive function. We don't yet know whether it has a long-term effect or what the precise mechanism of that effect is, but it's not the only study that suggests that. There are a number of studies that suggest that. Black carbon, we tend to think of black carbon as mainly having an impact in low-income countries, but this is a very recent paper on the public health burden of black carbon in the USA from Pat Kinney's group at Columbia. And this shows you the percentage of deaths due to black carbon at the country level. And you can see that certain parts of the US, over 1% of the deaths are due to black carbon, about 14,000 deaths per annum in total. And the investigators emphasize this is very much a lower bound estimate of the mortality. So it's about 12 or 13% of the, at the lower bound of the total air pollution deaths in the US. So even in a country where black carbon is relatively low, it still has a major public health impact, much of that coming, over 50% coming from transport. Household energy, fairly familiar with that, but again, major potential benefits from cleaner, low-emission cook stoves and fuel switching to reduce solid fuel use. And we know that this is not just the direct air pollution benefits, which are very, very important, of course, but also a lower injury risk during fuel collection and fewer burns as well. And likewise, improved lighting to replace kerosene lamps has an important climate benefit, although it says medium here. Of course, it is a very pure source of black carbon, so it is locally very, very important. And again, brings with it a substantial public health benefit, as well as, of course, solar lighting can provide opportunity for young people to study more, and also in the longer run is less of a financial burden on poor households. And this is a recent study which gives also quite an interesting result, which examines the question of whether early exposure to high levels of smoke causes impaired lung function in the longer term. And it takes advantage of the only randomized experiment of low or more efficient household cooking, which was done in Guatemala, by the way. And it's a long-term follow-up of that study, and it shows that children exposed to high levels of air pollution from traditional stoves in the first 18 months had a smaller increase in their lung function, in one very important dimension of lung function, as they got older than those exposed to modified stoves, which resulted in much lower levels of air pollution. So that suggests that this early exposure to very high levels of air pollution may produce a long-term impact on children's lung function. Recent evidence from Nepal, a study from Kirk Smith's group, a couple of papers that they've written, compared the effect of different fuels, kerosene, biomass, LPG, liquid petroleum gas, liquefied petroleum gas, and electricity on air pollution in Nepal. And they showed that indeed LPG does result in a reduction in air pollution, but it's really only with electricity that you get very low levels of indoor air pollution. And it's an important reminder to us that we need to look across a range of technologies when replacing very inefficient open fires or very inefficient cook stoves, and need to look at the potential of a range of different technologies. And it's interesting to note, for example, that you can now buy an induction hob for about $10. I mean, they've become very, very cheap indeed. They used to be hundreds of dollars. So this kind of technology is becoming much more accessible where there's reliable electricity supply. Food and agriculture, we've heard, is a very important contributor to greenhouse gas emissions, particularly methane. There's a lot of work now looking at the environmental impact of different diets. There's a diagram from the WHO report summarizing a number of studies, and you can see that ruminants, foods from ruminants, so beef and cheese, for example, have high emissions, as one would expect, and those relating to vegetables, even chicken and so on, much lower emissions per kilogram of food. So there's a lot of work now looking at the health benefits of lower emission diets. We've done some work in the UK showing that if you just optimize the UK diet to meet the WHO guidelines, you can reduce greenhouse gas emissions by about 17%. And you can get down to about 30 to 40% reductions without changing the diet dramatically, without going towards a vegan and vegetarian diet, just by rebalancing it to more fruit and vegetables and lower consumption of animal products. And that would also bring very major benefits in terms of reductions in heart disease risk. And then finally, of course, there are important economic implications, policy-relevant implications from some of these health co-benefits of SLCP reduction. And there's been a lot of work looking at CO2 mitigation strategies and looking at the valuing the health benefits of those strategies and how that changes the equation and makes mitigation strategies much more attractive to policymakers. There's been much less work in SLCPs. The best estimate we have is still from the UNEP WMO assessment report and in Drew's paper of 2012 in Science. It's estimated that the economic value of the health benefits of full implementation of the suite of SLCP measures that they looked at was around $5 trillion per annum worldwide. So that's a very, very major benefit using established economic measures of value of statistical life. And it does suggest that this is potentially a fruitful area for further research, also looking at the potential use of policy instruments like taxes on SLCPs, which could be a useful, I think, adjunct and help support policy change in the future. So I'll stop there and open it up for discussion.
Question.